All right, hey guys, we're going to start talking about our preliminary lesson 1 over functions here. And a function is just a way that we can show the relationship between variables. Right? Specifically, we have different types of variables. First off, we have independent variables and we have dependent variables. The dependent variable is listed as such because it's dependent on what the independent variable actually is. Those generally are denoted by X and Y. There are some people that like to say that you use the end of the alphabet to denote your variables and the beginning of the alphabet to denote your constants. And so what I've written here is the y equals mx plus b, the slope-intercept form of a straight line. It's a function that denotes the relationship between x and y with our constants of slope and y-intercept. A and b are the slope and y-intercept. Well, that's what our constants are. Those are our variables, and we'll get more into those as we go along. Now, one of the things that I really wanted to make mention here is the fact that this particular function is what we consider one-to-one. Okay, so a one-to-one, and this is how a one-to-one function is a function in which its dependencies actually go the other way. It's where you have one unique dependent variable to one unique independent variable, and honestly vice versa. And so I could give you this equation right here, give you the dependent variable number, you would be able to then solve the independent variable number. Okay, that's what that one-to-one really is talking about. Now sometimes we like to give you some equations, and let's actually give you one right now. This is going to be what is known as implicit, okay? So an implicit function is one that has the variables, both variables on one side of the equal sign, right? So we're gonna have like x minus y plus 6 is equal to 0. This particular format is one where this is implicitly stated. Now, most of the time we're used to seeing something explicitly stated, okay, where we have the f of x and all that stuff. That is very easily derived from this format right here. Now, how do we do that? Well, we can just move the y over. We add y to both sides and we have it in an explicit state. So let's actually do that, where we add y. And there we go. It's explicitly stated now in terms of x. Now, how does that relate to like what we usually denote a function as? Well, we say that y is our dependent variable, and we set that equal to the function. So we say y is equal to the function of x. And since we have the function of x explicitly stated as x plus 6, that's how we can go from implicit to explicit and vice versa. You can get to both of those fairly easily. Okay? Now, this is just one specific type of function. There are multiple different types of functions. This is called a linear. We have linear functions, we have quadratic, we have cubic, quartic, I could go on. There's also sine, cosines, tangents, secants. Those are our trigonometric functions. There's logarithmic functions, and then there's exponential functions. There are other functions as well, but those are the most common that we would actually use. Okay? Hopefully you don't have any questions over that. We're going to move on into what is known as multivariable functions. What's a multivariable function? Well, this is a function which would have more than what our one-to-one functions would have. One of the most common, and probably one of the one that comes to mind the best, is the Pythagorean theorem, where you have a squared plus b squared equals c squared, where the hypotenuse is directly related to two different variables here. This variable is related to these two variables. It's dependent on these two variables. We can derive this to get that c by itself. C is equal to the root of a squared plus b squared, and that's one of our multivariable functions. Another multivariable function that we actually use a lot is volume. Volume is also a multivariable function. We have three variables in that is related to what the volume is. The volume of the room that I'm in. Volume is equal to the length times the width times the height. We have three variables here that's related to this dependent variable of volume. Now, one of the things that we really need to talk about, those are our multivariable functions. You'll get more into those later on, especially if you get into higher levels of calculus where you have to actually do your derivatives of multivariable functions, and the integrals, triple integrals, those are fun. One of the things that we really need to talk about and make sure that you remember is the differences between our domain versus the range. Okay? So the domain, in all intents and purposes, is the set of numbers that are our independent variables. Okay? And usually those are denoted by x. The range, however, is a set of dependent variables in which we denote most of the time those by y. Now these are usually a good relationship. We can show the mapping so that it would be like a one-to-one, or if it's a function. But let's look at a couple of sets of these numbers. So let's give a domain a set of those 5 numbers. Okay? Let's say that they're mapped to a set on the range of these numbers. Okay, and they are mapped in that order, and we're fixing to look at the actual mapping of this as well. It's a different type of imagery that we can use to denote the function. If we have all of these unique domains, okay, and all of these are actually mapped to one other number. They are uniquely mapped. So this particular set of numbers, if we put these into an ordered pair situation, this is a function because each of the sets of the domain map to one part of the range. There's no part of the domain that has 2 arrows going off of it. That's what that looks like. Now, if we wanted to look at the actual mapping, where we have the set of the domain and the range, we can actually see if we do this mapping, it's not one-to-one, but it still is a function. So the 1 goes to the 2, the 2 goes to the 19, the 3 goes to the 2, the 4 goes to the 3, and the 5 goes to the 5. Now, on this side, this is what we're looking at to see if it's a function. Each one of these numbers is going to, only has 1 arrow going off of it. Now to see if it's one-to-one, we actually look on this side and see that, oh, this number has 2 arrows going to it. It's not one-to-one, but it's still a function. Now, if we were to, let's change this up just a little bit, where we get rid of one of the numbers in the domain, and we map this just a little bit differently. where we see this happen. The 1 now has 2 arrows going off of it. This is now just called a relation. It's not called a function anymore. Now, that's another thing we need to discuss real quick, is that all functions are relations, but not all relations are functions. One of the more common functions that does not seem like it should be is called a step function. Let's actually look at a graph real quick. So this is part of what we call a step function. Okay? Right now it looks like it's very broken up and we wouldn't actually call it a function. But because of the domain, because all parts of the domain are actually intact, and it doesn't map to 2 different points, one part of the domain doesn't map to 2 parts of the range, it actually still is a function. Each one of these, let's call them by 1, so this is 0, 1, 2, and 3. If we look, and then 1 and 2, if we actually look at this and we map it, we can go, these are our coordinate points here. So those are the coordinate points for this on each of those points there. We don't see this point here because it's not a part of our function. Okay, so this is one of those that would actually pass like the vertical line test when we're fixing to look at one of those, and it would actually pass the mapping test as well if we were to map it. Now let's look at one more graph. Look at that. Isn't that a pretty curve? This one, we actually are going to look at what we know as the vertical line test. If it fails the vertical line test, it's not a function. And so you take something like a straight line. I'm just going to use my hand real quick. And if the line actually passes through multiple points in any vertical line, imaginary vertical line, it fails the vertical line test and is not a function. All right, so we're going to get into more complicated things later on. You're going to be talking about limits in the next section. So I hope you enjoy that.